The broadcast is now starting. All attendees are in listen-only mode.
Well, good morning, everybody, and welcome along to the Database Administration Virtual Group hosted by myself, Warwick Rudd, down here in the Australian time zone. For today's session, we've got Anthony Nocentino talking to us about Linux OS fundamentals for the SQL admin. Now, before I do hand over to Anthony, I do have a couple of slides to run through. First off, for those of you who don't know about Past Summit, it is coming up next month. You can still buy tickets, and if you use the code here on this screen, then you can get a $150 discount off your ticket. Make sure that you register and come along to that. You'll actually get to see both Anthony and myself at Summit, so drop by and say hi. At the Past Summit, there are some community-hosted events, so if you are coming along, make sure you look out for these, come along to these events, and use them as networking activities. Right at the moment, we do have the past board elections happening, so make sure you log in and vote for your particular candidate that you would like to be on the past board for the next 12 months. The voting for that has already opened. Make sure that you do go in, as I mentioned, and you do go in the contest to win a registration to next year's summit. There are many virtual chapters that are available for you to join in, come along, listen to the sessions, just like today's session. Feel free to go to the past website. Make sure that you find the appropriate one that you're interested in, register, and you too can find out more about what's happening in those particular virtual chapters. For those of you in the US, Canada, Europe, or LATAM areas, these are your upcoming SQL Saturday events. If you haven't already registered, make sure you register, go along, and you've got a great day of free learning from some fantastic speakers at each of these events. Apart from the virtual chapters, you do have local chapters in your areas, so make sure that go along to those. You can meet the presenters in person, network with other people who are interested in the same types of topics as yourself. If you are interested in volunteering, then you can help out at any of your local chapters at the SQL Saturdays or at PASS itself. Go to the PASS website, fill out your profile and indicate that you'd like to be a volunteer, and you'll be contacted and pointed in the right direction. Now, the recordings this session is recorded and is available up on YouTube, so make sure that you go to the Database Administration virtual chapter and you will be able to look at this session later on. This is how you can stay in contact on Facebook, Twitter, or LinkedIn. And if you want to tweet about this particular session, make sure you use this hashtag. A little bit about Anthony. We won't go through this much. I'll let Anthony introduce himself with the session. So with that, I'll now hand over to Anthony and we can continue.
Cool. Thank you, sir. Thanks for having me. You might have said good morning, but it's definitely good evening on our side. But I do appreciate you having me. So let's get started. So this is Linux OS fundamentals for the SQL admin. And I am Anthony Nocentino. So I'm a consultant and trainer. I'm the founder of Centino Systems, since Warwick and I were talking about before this. We each run our own independent consulting firms. So that's something that I do. And it just means really we work a lot. I specialize in system architecture performance. So I like to design systems for customers, and I also like to make them go fast. So if you have something slow, I can make it unslow for you. I have an undergraduate degree and a master's degree in computer science. I've done a lot of research in spatial database systems and high performance database systems. Microsoft MVP for this year, Linux Foundation Certified Engineer. So I have a nice confluence of abilities or experience in both of those worlds. So the SQL Server on Linux thing is totally cool and lines up with what I've been doing for a long time. I also have some contact information for you guys there. I actually reply to the email, so please, if you have any questions about today's session, do email me or follow me on Twitter. You can hit me up there, and that's my Twitter handle. And it's kind of the most common way for me to get information out to the community for things like blog posts, and that's my blog. And I'm also a Pluralsight author. And today's course, or our talk today, is rooted in a lot of work I've done for Pluralsight, and I have a lot of deeper dives out there for you guys on the content that we're going to go through. And if you'd like, I can give you a 30-day code, and you can go and kind of dive into these topics in more detail, not because I'm trying to sell you Pluralsight, but because I want you guys to have access to that content if you want to go a little bit deeper on some of the topics that we're going to cover today. And so I'll kind of highlight those as we go through today. And we're going to cover a lot of turf today. We have about an hour. I have a tendency to go a little bit long, but we're going to go through a lot of things. And certainly I can't teach you an entire operating system in an hour, but I'm going to show you the things that I think are really important for you to get started on your journey about learning Linux, right? Because it's an operating system and there's a lot of stuff there, right? And what you're going to find out when we get to the end is a lot of those things map back to things that you're already used to. And so the things that we're going to go through today, right? We're going to look at Linux's architecture, like what it looks like on the inside, and we're going to look at how we can interact with that system. How can we make it do the things that we want to do? We're going to talk about kind of the core of the Unix philosophy around this concept of IO redirection and pipelines, and we'll look at that pretty closely. We'll go over file system basics very quickly, just to kind of show you where things are on the file system. And if you don't know, there is a version of PowerShell or PowerShell Core that is now available for Linux. So maybe we can connect some dots back to the Windows people that are familiar with PowerShell and make you more proficient in Linux, leveraging PowerShell. Of course, we need our systems to do stuff for us, right? So we need to be able to install things. We're going to look at some package managers and how to get things installed. And we're going to look at how to manage services with systemd, right? You guys might be used to managing services with PowerShell, with the commandlets there, or in the graphical console with services.msc. And we can look at that a little more closely with a thing called systemd that provides that functionality in the Linux world. We're going to look at some system resource manager. We're going to look at things like CPU, disk, and memory, and where we can poke and prod to get some good performance data. And of course, getting help, right? If we're new to this, I want to point you to the right stuff so that you can get the resources that you need to answer those questions that you might have while you're going through this journey. And so the Linux architecture, right? We're going to go through what an operating system really does. And operating system's primary function is to control hardware, right? I want to have access to physical resources, things like CPU, memory, disk, network, things like that. And so the operating system consists, especially Linux, and most operating systems consist of what's called a kernel. And it's the kernel's responsibility for resource management and access, right? Who am I going to give access to which physical resource and when, right? So we have these constructs like processes and memory pages and file systems that control access to things like CPUs, memory, and disk, right? And as we kind of move up this kind of architecture and the stack that I'm kind of building here for you guys, we have the shell, right? And the shell, that gives us our ability to interact with the kernel, right? I can execute a command and I can ask the system to do some work for me, right? So I can execute something like a directory listing, and that's going to go and it's going to interact with the kernel, and the kernel is going to go traverse the file system, read those blocks off the disk, and show me what those things are made of as it kind of goes down the stack through the kernel via a system call interface into the hardware itself. And of course, at the top of the stack, there's us who interact with the shell. We tell the computer what to do, and what we do is we just cause problems. But there's two terms I want to throw at you guys today that you kind of keep in your brains for kind of slicing and dicing what's where, is we have kernel space and user space, right? Those are the two-way things where we kind of transition between the two based on the work that we're doing, or that the computer's doing, excuse me. So now that we know what Linux kind of looks like architecturally, right? Let's look at how we're going to interact with a Linux system. And fundamentally, right, if we're talking about being DBAs, we're probably going to have servers, and those things are going to be sitting in a data center. So we're going to generally interact with those systems with text via either a console or via SSH. What SSH is, it allows me to remotely connect to a system securely and interact with that terminal so I can execute commands with a command line interface. And primarily, if you're using a Linux or Mac, you're going to use the terminal app. Or if you're on Windows, you're going to use something like PuTTY. So if you look at the screenshots there on the right, we have a screenshot of an actual console, the terminal app, and also PuTTY. And I'm just interacting with that same system in those very different ways. We, of course, do have the ability to have a graphical console on our system, right? So those things for things like Red Hat Linux or CentOS. Is going to be GNOME. There's also KDE and many different desktop managers out there, but those are kind in that world. For kind of remote desktop capabilities, we have VNC, or virtual network computing, and that's going to present to me a graphical desktop interface on that remote system. Not exactly like RDP in the sense that you get a session into the server, but you actually get access to an individual desktop itself. I do cover these topics in much greater detail in one of my Pluralsight courses if you guys want to go into that. So now that we're on our system, right? So we're sitting at the console, we need to figure out where there's two different ways that we can interact with our system, right? We have regular access and privileged access. And to do that, Linux security identifiers are really how we kind of slice and dice that. And there's a special security identifier in our system for the root user, or UID 0. And that root user is analogous to the individual or local administrator of an individual system on the Windows side of the house. And root is that account on the Unix or Linux side of the house. And conventionally, and that's going to give you privileged access. And so conventionally, when you log into a system, you're going to be presented with a shell, right? And in this case, I have a bash shell that I'm showing here in a screenshot. And conventionally, when you're logged in as root, you're going to see this hash sign here. So it's going to see username, right? So root at the host name. My host is rel1. The tilde just means I'm in my home directory. And that hash mark there conventionally indicates that user has privileged access. Of course, I can make that character be anything just by changing my my command prompt or how it's presented, but conventionally it's going to be a hash mark. You want to try to avoid using a root because bad things can happen when you're logged into a system with privileged access at all times. Very similar can happen on the Windows side of the house. We generally don't want to run as local administrator because we want to kind of run with the least privilege when we're doing the tasks that we're trying to do on our systems. So in that case, we really want to operate as regular named users, right? We can have local users on a system. We log in as that. And in that case, you can see we're going to have a $sign at the command prompt there. So we see the user demo at rel1 and then a $sign at the end of our prompt. Again, totally configurable. It's just that's what's out of the box convention. And so now we have this concept of regular access, right, and privileged access, and we need the ability to switch between the two. And we have a couple of ways that we could do that. One way we can do that is with the su command, which is short for switch user. What the su command does is it allows you to switch your security context from one user to another, right? So I can log into a system as the user demo, and I can use the su command to switch to any other user, including that root user for privileged access. But the su command requires that you enter the destination user's password, which means if I wanted to switch to root, I would need to know root's password, which kind of undermines the whole idea of a security concept of handing out root's password to everyone that needs access to it. So we have this other way that we can do things with what's called sudo or sudo. And what that does is it allows you to have the ability to execute the command or a command with privileged access. So I can type something like sudo space and another command, and that command will be executed with privileged access. And it's not that that's wide open to the entire world. We can very granularly configure that. I could say that this user can only execute these commands. But a common thing to do is to combine sudo with su, right? Giving users the ability to do this in the configuration file. I can combine sudo and su and switch into that root user's context, but now I'm using my password, right? And I'm able to get into that root user's account using my password rather than having to distribute that root user's password to users. One other concept with su, when I combine those things together, if something like sudo space su, I generally am going to want to put a $sign at the end of that. What that means is I'm going to load the destination user shell when I get into that user's context, because when I'm logged in as root and I want to do privileged access to certain commands, there's certain directories that'll be in the root user shell or path, excuse me, that I want to have access to. So the most common command sequence is going to be sudo space su and a $sign. And we'll look at that a little bit later in a demo. So I love kind of computer and computer history, computer science history. And so Brian Kernighan and Rod Pike, if you guys don't know who they are, I freely excuse you to go Google them right now, look them up on the Wikipedia and find out who they are. Brian Kernighan is one of the forefathers of the Unix operating system, the C programming language. Rod Pike did things like invented DNS and I should say contributed significantly to DNS and invented a whole slew of Unix command line utilities that we still use today. Totally fantastic people, part of the Bell Labs research projects. And in their books, one of their books, The Unix Programming Environment, there's this quote here, and it's kind of stood with me for a long time, is that many Unix programs do quite trivial things in isolation, but when I combine those things together, they become more general and useful tools. And this is the core of the Unix philosophy, right? This is why I'm able to build very complex commands with the most simple tools and do very cool things. So we're going to look at the plumbing behind that and how it all works right now. And really the root of this is a concept called IO redirection. And we're going to look at that very closely. So inside the process address space of a system, in a Linux or Unix process, there's going to be a collection of file descriptors. What a file descriptor is a place where I can read and write data from to interact with things external and internal to a particular process. So in this case, I have it's going to be three file descriptors. We're going to look at the first one, file descriptor 0, or standard in. So whenever anything wants to come into this process, that's where the process is going to read its information from by default. And so primarily when a process starts up, I'm going to interact with it via the keyboard. I'm going to give it some commands, right? And it's going to execute the process. I'm going to potentially give it input from the standard input or file descriptor 0. Now, when that process has to write data out, by default, what it's going to do is it's going to write it to file descriptor 1, which is standard out. And by default, standard output is going to take that information and write it to the terminal. And so you can kind of see that there's going to be a flow between our programs here in a second. There's also a third file descriptor 2, or standard error. And what that by default does is it writes the terminal as well. What this does is it gives us the ability to take those errors that are being written in our process and maybe potentially take them and move them to a separate location, right? If I need to write them to a file. So I can take these things, right, these file descriptors, and redirect where I want them to go. So in this case, I just took file descriptor 2, which would have written to the terminal normally, and now I have it right into a file, right? And I can go back and investigate that thing later. And we can go through that, and we can also change any of the file descriptors to a different destination. So the standard out, which previously wrote to the terminal by default, I can have that write to a file as well. We've probably all done that before, where we execute some command, right? We put the greater than sign and then a file name. Well, this is literally how it works under the hood, even on Windows systems. And we can also, from standard input, say we can read information in from a file and push that into a process via standard input. So these things are totally configurable and are the core of how pipelines are built. So we're going to look at those now. So text-based pipelines or byte stream-based pipelines. If you're from the PowerShell world, you might be familiar with an object-based pipeline. Well, this is kind of the foundation of that. That's the source of where those concepts came from in PowerShell. And so when I'm executing a process, let's say I want to get a directory listing, right? And I'm going to have this thing, it's going to spin up, I'm going to interact with it via the keyboard. And what happens if I have a huge directory listing? It's going to run up the screen, right? And so Unix gives us a command called more. And what more does is it takes one page of input, puts it on a screen, and then stops. And I hit the space bar and I get another page of input, and then it stops. And so I can combine these two things together, right? So the output that was flowing off my screen very quickly when I typed ls, I can pipe that information with the pipe sign into more. And now I get the directory listing, one page of content. I can view the directory listing, and I can go and read that, hit the space bar, and get the next set of information. And it's not just limited to ls, that's any command, right? It can build these things together. And the plumbing under the hood is that the file descriptor 1, or the standard output, that buffer is
Hey guys, can you hear me? Just send a message. Okay. So,
Hey, there we go. You guys have me back now?
we do.
Cool. So, did you hear me make the bad joke about the file system hierarchy standard?
No, sorry.
Okay, so the file system hierarchy standards. If you guys want to fall asleep early tonight or work, if you want to take a nap this afternoon, go and Google the file system hierarchy standard. In there, you're going to find a rigorous definition for each and every one of these directories, telling you what's supposed to be there. And what's cool is that's standard, right? It's a standard across most Unix file systems. And so you kind of have a good thing that you can go off of from a reference standpoint on what's supposed to go where. I think that document's like 70 pages long. Fantastic reading. So PowerShell. So I'm a big PowerShell fan. About a year ago, I got involved in PowerShell on Linux, which at the time was open source PowerShell. Now it's been dubbed PowerShell Core. And I'm all in on PowerShell from the automation standpoint. It's really accelerated my ability to get things done. If you guys are using DBA tools in the SQL Server world, you know exactly what I'm talking about. You can leverage those same concepts or those scaling out concepts of PowerShell in your Linux systems. I'm bringing up PowerShell for you guys today because I think it can help you guys bridge the gap from a command standpoint. Because one of the core reasons why the PowerShell team did bring PowerShell to Linux and Mac is the ability to have one single language, right, or scripting language to control the system, right? If I can type a commandlet on a Mac and on a PC or a server and on a Linux server and get the same output, that means I can use that same code in all those places. That's a super valuable concept that I can get some economies of scale in my system automation. So PowerShell Core is now in beta. They're doing about every 3 weeks or a monthly release. Pretty much every time I see a release, I send a tweet back to the program manager that says, clearly you guys know I'm doing a presentation tomorrow and I have not, I'm tempted to update to the latest beta that you've deployed. And I get some funny tweet back saying, whatever they would say. So one of the things that you can do is we talked about the default shell, or we talked about Bash in the beginning as our shell. With Bash as your default shell, if you want, you can make PowerShell your default shell. And I'm not suggesting that you do, I'm just saying that you can. And leverage that to kind of help you guys get under the hood a little bit further inside of a Linux system. The PowerShell remoting concepts apply in Linux as well. I'm going to show you guys how to log into a system with SSH in a second, but we can also leverage PowerShell remoting, which actually leverages SSH as its transport layer. But if you do want to manage both Linux and Windows systems, you'll need to put SSH on all the systems, right? And so Linux has SSH installed by default. Windows, you could install OpenSSH on there as well and leverage the same remoting techniques using OpenSSH across your entire platform. Actually, that is no longer correct. That was fixed in a previous release. If you're familiar with the concepts of legacy remoting in PowerShell, where we would process the list serially for the systems that we're interacting with, that was the case in earlier releases of PowerShell and Linux. That is no longer the case. They do have parallel remoting. WSMan or WinRM-like remoting exists in Linux today, but I caution you, it uses basic authentication. I think so. We don't have Kerberos. I would not use that in a production environment until they get that sorted out. That's certainly in their development pipeline for the PowerShell team. If you guys do go down the PowerShell route for using that to manage your systems, what I do want to caution you that if you're using PowerShell on Windows and PowerShell on Linux, you might be used to a couple of Unix commands that were aliased inside of PowerShell on Windows, things like move, right? MV on Windows PowerShell is an alias to the commandlet move item, which can put you in a bind. If you're on a Linux system, you type MV, because what's going to happen there is it's going to execute the native command, the actual binary. The PowerShell team chose, rightfully so, to not have those aliases that they have Windows PowerShell stomp over their actual Unix commands. Things like MV and LS are common. I think cat is another one that they aliased for you guys. really, this is going to impact you if you're expecting output on your pipeline. We talked about byte stream-based pipelines or text-based pipelines a little bit ago. If I write a script or if I write a command and I'm expecting a particular output type from a commandlet or a native binary, they're going to be different, right? If I type MV on a Windows PowerShell system, I'm going to get object-based output. If I type MV on a Unix system, well, I'm not. I'm going to get the output that I would normally get from a Unix process there. So if you get lost, obviously we have the commandlet get alias to orient us there. And if you are writing scripts, just be as explicit as possible in your scripts. Just basically don't use aliases in the scripts, and you'll probably get better quality code that you can run in multi-platform environments. And so let's go ahead and get into our first demo. If you guys have any questions as we go through this, go ahead and ask. I'd rather you guys kind of throw things at me and we can navigate the demos to how you guys want to see. The first thing we're going to do is we're going to connect to a remote system with SSH. We're going to do some basic process management with get process, and we're going to look at PS, and we're going to look at building command pipelines together. So I have a Linux VM up and running on my Mac, but we're going to connect to it from my Mac with SSH. And so the way that we connect to it is like this. So we say SSH, which is the command that I'm going to execute locally, then my username, so demo, @ and then the host name. So here you can see server 2, and I go ahead and press enter. And it's going to challenge me for my password eventually. And here we are logged into our system. And this is a Linux server. It's I'll show you guys this, a CentOS 7.4 VM that I literally built fresh for you guys yesterday. So it's hot off the presses. And let's go ahead and get started with our demos. And so if I want to ask the system, right, if I want to execute a command, we simply can type a command at the command prompt like so PS, which is going to give me a listing of all of my processes on the system. So you can see here I have bash and I have PS. Now, if I want to get a list of all the processes on a system, right, this Linux system I'm working on, I type PS space -aux. And you can see what it does is I'm going to scroll up here, which usually doesn't work well when you're doing demos. I have a huge listing of things. And it just kind of flew off the screen pretty quickly. And let's go ahead and build our first commandlet, our first command together. We're going to build a text-based pipeline. I'm going to take PS, right? I'm going to give it the -aux parameters. That's going to have that huge flow of output. But this time what it's going to do is rather than go into the terminal, it's going to hit the pipeline and it's going to go into the standard input of more and give me 1 page of output, right? And we talked about what more does behind the scenes a second ago. And so while we're here, let's go ahead and look at the information that we have, right? In the very first column, we have the user that all of these processes are executing as, and each row is an individual process. We have the process ID, which is a numeric integer that represents an individual process. The percent CPU utilization, we have the percent memory size here. So you can see the very first thing is taking up 0.1%. Then we have with the virtual address size, right? So that's the amount of virtual memory assigned to this individual process. We have the resident set size, which is the actual amount of physical bytes that are allocated to this process at this point in time. We have our terminal, and you can see the question mark there means that none of these processes are attached to terminal. So I'm going to go ahead, if I go down to the bottom, let's go ahead and check that out at the bottom here. You can see my SSH, or excuse me, my bash process is attached. So it's called a pseudo terminal or pseudo terminal 0. And that's what happens when I log in via SSH. I get attached to a pseudo terminal. That pseudo terminal launches my bash process. And then I get into the ability to type commands at the command line like this. Let's go ahead and look at the rest of those. We have our process status. It's a little bit out of scope for today, when the process started and how much CPU time is actually consumed. And the final column there, we can see the actual process name itself. Regular processes or user processes are going to show up as the full path there. Kernel threads you see are in brackets. So when I have this huge command, so let's say I want to do something like sort through this list and pull off the top 10 processes, and I want to build a pipeline to do that. And so again, I just did PS -aux and it flows off the screen. Well, there's commands that we can use, things like sort, that will sort the output of data that's coming through the pipeline, right? So I go ahead and it's going to sort that stream. Well, first and foremost, it flew off the screen again pretty quickly. But if you notice what it did exactly what I asked it to do, right? It's one of those things, computers always do precisely what you tell them to do, not what you want them to do. And what it did is it sorted the data alphabetically, or ASCII sorted the data by the very first column, right? And from left to right. And you can see what happened is the header data shoots to the bottom, right? Because it's an ASCII sort, so capital U is after R and root, and so I have like unsorted output. our goal here is I want to get the top 10 processes from a CPU utilization standpoint. And so to do that, I need to tell sort to treat its data differently. And to do that, I need to do something like sort minus NRK3. What that's going to do is, you're probably like, whoa, NRK3, right? Well, yeah, that's kind of muscle memory because I've been doing this for a long time. But what that really means is numerically, in reverse order, by key column 3, right? Column 3 is CPU. And so now we'll have some nice sorted data, but again, it flows off the screen. So I'm going to do one more command, and I just want to get the top 10, right? So I'm going to leverage another command. So we're building a longer pipeline here by adding another command on the end, head. And what head does, it gives me the top 10 processes, or actually, excuse me, more precisely, it gives me the top 10 lines of output across the pipeline. Of course, I can increase that and just say minus N11 if I wanted to get just an arbitrary, the 11 processes, and kind of float with that and change that around if needed. So the final thing I want to show you guys today is let's do the same thing in PowerShell. So in PowerShell, we're used to doing something like get process, and we'll do something like sort object because I want to sort the output of that object. And so let's go ahead and look at the get process output. So that flows off the screen again. And let's go ahead and go through this and do sort object. We'll do descending CPU, right? And we'll do one last commandlet, select object dash first 10. And so we're going to get the same output, but it's going to be structured totally differently. And the way that we got there is a little bit different, right? Where you leverage PowerShell commandlets to do this. And honestly, even after 20 years of being a Unix person, I kind of like looking at the PowerShell stuff first. I mean, the stuff on the bottom line there, the PS minus AUX pipe sort, that's been in my brain for a long time. But if you're new to this, right, and you're using the tools that you're used to, you could still get those things done that you need to. So it's something like get process, pipe sort object, descending CPU, select object first 10. That's very readable and very consumable to a person that's doing this for the first time. So with that, let's get back to, where's that keynote, some hand wavy stuff. All right, so now that we know how to interact with our system and we know how to build pipelines, right, and how that information flows from commandlet to commandlet, or command to command and commandlet to commandlet, let's kind of move up the stack a little bit further and talk about package manager. Right? We need our computer to actually do stuff for us. I want to be able to install software and upgrade software and work with our system. And I'm going to focus on CentOS or RHEL-based systems today that leverage a thing called RPM, or the Red Hat or which used to be called the Red Hat Package Manager. Now it's just the RPM Package Manager, RPM. What that is a package management system. And a package is a collection of programs, scripts, and metadata about the thing that I want to install. And so when I say programs, the actual binaries and the surrounding materials that go with that, so scripts and configuration files. But most importantly is the metadata about those things. I can install, the metadata inside of a package maintains all of the contents of the package, so all of those files and scripts and the things that are included, but also version information. So I can know on my system, I'm on version 1 of a piece of software, version 1.1, and it can help me transition between the two. What RPM provides is a suite of management tools for me to be able to install, upgrade, and remove packages, ask packages for information, like from their metadata, and make decisions on what I want to do with things that I want to install. But what's interesting about RPM is I can install a package. So I can say, RPM minus I, package A. And if package A required another package, like package B, which those dependencies are tracked inside of the metadata in the package, if I want to install package A and it needs package B, well, RPM is going to say, hey, you need package B, installation failed, and it's not going to do anything about it. These concepts also apply into Debian and Ubuntu world with programs called apt and dpackage. So conceptually, these all match up, just the syntax is going to be a little bit different. So how do we deal with dependencies, right? Well, there's a thing that came out a little bit after Yum, or our RPM came out, was Yum, which is Yellow Dog Updater Modified. I think it was from Duke University, in one of their research departments just needed this functionality, so they built it. And what they built was a dependency management system around RPM, right? So we have now Yum providing that dependency management of, if I type Yum space install package A, and it's going to be like, hey, you need package B. What Yum's going to do is it's going to reach out to what's called a repository, download package B, install package B, and then install package A and fulfill that dependency for me, which is fantastic, right? I don't have to deal with this on my own anymore. And I use the term a second ago that I didn't quite define, which is a repository. And what a repository is a place where we store other packages. And so those are going to come from places like our software publishers, like Red Hat, CentOS, and those mainline software publishers that are deploying things like Red Hat Linux or CentOS. There are also third-party packages out there, things like the extra packages for Enterprise Linux or EPEL and the RPM Forge. Now, third-party repositories become useful because sometimes there's going to be packages that aren't in the source or base repositories that Red Hat and CentOS provide that you might want. And the primary example from this is a couple of years ago when MySQL was at version, I believe, 5.5, that was being released from the MySQL team, but Red Hat was only released version 5.0 in their base repository. So I had to go to and I added EPEL and I installed 5.5 so that I could get that package out of that system and get all the goodies that Yum provides from automated or updates and whatnot and dependency management for the system that I was working on. In a little bit together, we're going to install Microsoft's repository together, right? Which is essentially a third-party repository so that we can consume RPMs from Microsoft. You can, of course, build your own repositories as well. There's two ways you can look at this. You can actually package your own RPMs and deploy them to your systems internally. Or if you're running updates or things like that, you can actually sync Red Hat or CentOS's or any repository locally onto a system internally and run your updates off of that, thus saving your bandwidth in your data centers, or if you're not allowed to access the internet in your data centers, it gives you the ability to run updates securely without having to reach out to the web. Yum also provides the ability to do system-wide updates. So I type Yum update, I mash the enter key, it's going to update every package on my system, which is a fantastic piece of functionality. What you might be turned off though, when you do that, when you type Yum update, you might see, wow, my base system has like 784 updates or whatever it is. And it's a little bit different. Remember, we talked about Unix systems have a lot of tools that do simple things and do that one thing well. And so you might see, or you might get scared off by seeing, the 7,000 updates that are available, but don't. Those packages are generally smaller things and not these huge monoliths that you might be used to. Again, dependency management and all that fun stuff provided by apt and dpackage in the Debian CentOS, or excuse me, the Debian Ubuntu side of the house. One common question I do get is which distribution do you suggest? And this is my super generalized cut for it is if you're in a data center, you're going to use Red Hat or CentOS, right? Because you're going to want to have the support that goes around that comes from Red Hat. And if you're a developer, generally you're going to lean towards Debian and Ubuntu. Again, that's my gross generalization. Of course, there's overlaps in both of those things, but that's kind of how I've seen that fall together over the years. So now we're going to go and we're going to look at some package management with Yum, and we're going to install SQL Server on Linux together using Microsoft's Yum repository. And I'm going to do a little bit of cutting and pasting today, but I'll read the commands to you. It's just because there's lots of URLs and things that can be challenging to type.
Anthony.
Sir.
2 quick questions before you start on your demo.
Yo.
First question, we don't seem to have an invoke SQL command in PowerShell. I tried to overcome this with SQL CMD. Any idea about why invoke SQL CMD is not present?
Let's just do it together. So yes, I do know why. There's a particular library that hasn't been cross-platformed over to Linux yet. So if I do something, so if I go and I do PowerShell. So here's the first time I'm using sudo today to show you guys. I'm going to run sudo in PowerShell because PowerShell is actually going to run as a child process of the shell that I'm in right now. So sudo PowerShell is going to run PowerShell with escalated privileges so that I can do something like this in install -module. Type, Anthony, type module SQL Server. I believe that's the module name. And it's going to tell us the exact library that it can't quite meet the dependency for. And I'm not 100% confident, but I'm fairly confident that once that gets cross-platformed, this will just work, which really means the module in .NET, instead of using .NET full CLR, we'll use what's called .NET Core, and then they make that transition, then we'll be good to go. So it's coming, I guess is the point I'm trying to say.
Okay, so
yeah, you can see it's gonna Yeah, you can see right there, it's unable to load that particular DLL to do the things that it wants to do for installing that module for SQL Server.
Okay.
You said there was another question?
And the second question was, I was trying to send email via PowerShell. It failed with the error NTLM authentication is not supported. I tried to use anonymous authentication. It didn't work as well. I ended up using Linux native mail command. I need send mail PowerShell commandlet to work well, as Linux mail is not good with HTML outputs. Am I doing anything wrong here?
So not knowing, this could be a mail infrastructure issue. Not knowing your mail infrastructure specifically, and I've never actually used the mail commandlets. Well, hold on, I think there was like once or twice where I copy and pasted some PowerShell code off the internet to send an email. What's going on under the hood when you type mail on a Linux system is that mail is actually going to be delivered to the local mail daemon. Every Linux system actually runs a mail daemon. It's either going to be send mail or postfix. Nope. So yeah, so you can see here, I'm running postfix on this system, and that's going to receive the mail and send it to where it needs to go. So when you type mail on a Linux system, by default, if I did mail type -s, and I want to send something to me, and what it's got, this message, when I type enter, mail's not installed because this is a base installation, but that's the command that you would type. That's going to automatically deliver that mail to the local mail daemon. That local mail daemon is then going to send it to the next hop mail router in its mail flow that's configured. I don't know how the PowerShell commandlet works. If it's asking for NTLM authentication or some other method, perhaps it's interacting with your mail infrastructure somehow, or the commandlet expects something by default that we're not quite providing. So I don't know precisely. So I apologize.
Thank you.
So we good on questions, sir?
We are.
Cool. So let's use, now I'm actually going to use sudo again. And so what we're going to do here is, if you notice, I'm logged in, right, as a non-privileged user. I'm just logged in as demo and indicated by the $. And I need to do something special to add a system repository, right? So I'm going to use this command sudo to execute this next command with escalated privileges. And we looked at it a second ago with PowerShell when we were answering the question, so I kind of jumped the gun, but let's do this piece as well. What curl is going to do, curl's a command line web browser. And what curl is going to do is it's going to browse to this URL, and it's going to bring that stuff, that content down, right, at HTTP packages, Microsoft.com, yada, 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 mssql-server.repo. And it's going to write that output with this -o parameter into this file, right? And inside that file is the definition of a third-party repository. So /etc, right? That's where all of our system level configurations are going to live. yum.repos.d is the directory where we define our additional yum repositories, and we're going to add this yum repository, and we're going to give it a name, the file mssql-server. So it's going to download that content, and let's go ahead and look at the contents of that file. And what we're doing is we're telling our system that it's now going to participate in this repository. So when I type a command like yum install, it's going to go and it's going to ask this repository potentially for the information that it has, and can it meet the dependency of the thing that I'm trying to install. So inside this file, we have a configuration name, so that's going to be what's in the brackets here, and then the actual repository name, so it's going to be packages-microsoft-com mssql-server. The base URL is where these resources actually are, right? So when I type something like yum install mssql-server, it's going to go and it's going to bring the content over HTTPS down to my system and install that RPM locally. And so now you can see why we need internet access to go and access repositories. This can be a file URL, this can be a DVD drive, an NFS mount. It just all depends on how you want to configure your systems internally. We have the ability to turn them off and on just by taking that binary option from 0 to 1. And core, absolutely core to how repositories work, because if you think about what you're doing is I'm just tuning my system into some arbitrary, in this case it's Microsoft.com, but some thing on the internet, and I'm downloading content from that system and I'm installing it on my local system. That's kind of trippy if you think about it. So I need to have some security that says that remote system that I'm interacting with is the system that it says that it is. And so we have a GPG check to verify that remote system is the thing that says what it is, and it does that for us. And so there we have installed our first yum repository together. The additional repositories you'll find inside of either yum.conf or yum.repos.d, which is where we put this individual repository. So to do our first installation together, we do something like this. And we'll walk through this together. So sudo, again, we have to escalate or run this thing with escalator privileges, right? We're installing software, and I'm not just going to switch over to root and install everything and stay in root and potentially put my system at risk. I'm going to execute these commands leveraging sudo. Yum is the command that we're executing, right? We're going to use yum, and the parameter is install. So we're going to install the software. This -y option, I get a yes/no prompt at the end of the installation. Well, it's going to answer that yes automatically for me. And the thing that I'm going to install is the package name MSSQL-server. And so I hit enter, and what it does is it goes and interacts with all the repositories configured on my system. So you can see base, extras, you can see MSSQL server-prod. Let's scroll back up for you guys, or MSSQL server. I also have packages that's microsoft.com-prod. That's where PowerShell came from. That's also where the SQL, the native SQL tools are. There's a package called MSSQL-tools. That's going to come from the prod repository. So SQL CMD and BCP come from that package. So now you can see what it did is it went and it resolved all the dependencies. I had no dependencies for this individual package. So it didn't have to go and get anything else. Now it's going to go ahead and give me a summary of what it's about to do. I have that yes prompt that automatically answers the question for me so that it's doing a download while I'm talking and explaining this all to you. And it tells me what it's bringing down. It's going to download MSSQL Server for x86, the particular version, where it came from, and its size. And it's going to install that one package. And here we can see it's pulling that down, and we have about a minute to go. So while that's going, I'm going to jump back into the presentation, and then we're going to loop back, finish the configuration of SQL Server, and also look at how to manage those services together. See, now you can see why I put -y on there, so I can go over here and talk while it's doing the heavy lifting under the hood. So managing services with systemd. I talked a little bit about this during the introduction. You guys are used to things like services.msc or the management console that interact with starting and stopping and disabling services and defining dependencies and things like that. Well, we have the same thing or same concept in Linux with the thing called systemd, but systemd doesn't just do service management. It's actually what's called an initialization daemon, and also provides a bunch of other services to help manage your operating system. The primary function of systemd, if you want to zoom out super far, is it's really for booting the system up and bringing it into a usable state for the user and transitioning between those states, right? So things like single user mode with networking, multi-user mode, and these different targets that are available. And those different targets define those different states. But we're going to zoom in on services, or what's called service units right now, and service control. The way that we control services in our system is with a program or a command called systemctl, or system control. And using that, we can do things like verify if services are up and running and interact with them. So we can either set them, we can disable them or enable them, check their status, start and stop them, and interact with those things using systemctl. Now, when we're talking about services on systems, what services really are a type of unit. And so systemd, like I told you before, manages a lot of different things about your system, and those things are abstractly identified as a unit, and particular types of units, like things like service units, file units, there's timer units, file system units, directory units. There's probably 20 or 30 different ones that are available to us. They're defined in what are called unit files, right? And so that text file defines the function of that unit. And so we're going to look at SQL servers in a minute. Inside of there, you'll see things like where the binary lives, what its dependencies are, right? So what the SQL server needs started up before, what can start up after, right? Things, the concepts that you're probably used to from manipulating services inside of Windows. And we'll look closely at those in a second here. Systemd also provides another critical function of logging. Conventionally, Unix systems log into /var log as text, right? And we found over time that it became hard to manage all these different text files. And so systemd provides a facility called journald, which is a way to store and aggregate logging information to one place from a lot of different things, right? And so SQL Server, by default, and many other programs will sync their logs into journald. And to access that data, we need to use a command called journalctl. And what that would do is query the information in our journal. And so we're not going to zoom in super far on that, but I do want you guys to know that login information lives inside of journal D, and you can leverage journalctl to go and Splunk around through there. I do have a whole module on System D in one of my Pluralsight courses where you can dig into that for about an hour and a half. So much fun. So let's go ahead and get back into the demo. We're going to leverage systemctl to do all of these things. We're going to enable a service, disable a service, check the status and look at that, and start and stop a service. So let's go and do that together.
So Anthony, just before you quickly jump into that.
Sir.
So what do you think is the major difference between SQL on Windows and SQL on Linux at the OS level? Does SQL on Linux have more security, and is it more stable than on Windows?
So first and foremost, I'm not a security expert at all, but I will tell you, that's a very hard question to answer. And in the second part of that was that performance?
Is it more secure and stable?
Stable. I have no inclination to believe that it's unstable. I'm trying to think of from a stability standpoint. If you're familiar with the architecture of how SQL on Linux was implemented, let me pull up another deck here. Hold on, I'm going to pause this just for a nanosecond. Because I want to show you guys something that I'm working on, but I don't want to quite indicate where it's coming from. Yeah, there, we use this. So, can you guys see my screen again? Am I good? Sharing. Showing main screen. Okay, can you see my screen again?
Yes.
Cool. All right. So you asked about stability. It's hard to define what that means because we're in a totally new way of deploying software and how SQL Server was deployed. So you guys may have seen this picture before. If not, there's where I got it from at the bottom, a blog post from the data platform team. Really what's going on inside the core of SQL Server on Linux is you're running literally the same Windows binary inside of basically a process virtualization container. And that's, the product team will not like the fact that I use those words, but we're putting a wrapper around the SQL Server process itself with this thing called SQL PAL, right? And that SQL PAL then talks to the operating system via essentially what they call ABI calls, or the things that are required for SQL Server to reach out to the operating system for, right? So inside here, literally the same binary image that executes in Windows, SQL PAL makes this process think that it's running on Windows. It then interacts with the operating system via the host extensions, right? So basically anytime it has to reach out to the operating system for the things that it's in control of, right? Remember way back in the beginning, the operating system's in charge of hardware. So network, disk, memory, and CPU, right? So that's basically the major function of the host extension, which then actually interacts with the operating environment or Linux OS. So is it stable? I don't know, right? And I'm sure the product team would be extremely interested in that answer as well, right? Because this is totally uncharted territory for production systems in deploying software this way, right? Process virtualization has been around for a long time. This concept where I provide an isolated environment for an individual process to make it think that it's executing in a particular fashion. But we haven't seen this in a corporate data center. In the corporate data center yet. Excuse me. 1 second, I'm gonna mute. So hopefully that answered your question there.
Okay. Two quick, or hopefully quick questions. So will SQL Server run on any Linux distribution and release?
Will SQL Server run? So the supported releases right now are RHEL, Ubuntu, SUSE, and Docker containers, and inside the Docker container it runs Ubuntu. The answer to that question is solely up to the product team. Different parts of SQL Server has requirements, right? This is kind of my view of how I see supportability for the platform. It's going to have requirements of the operating system, right? It needs to do certain things, and the operating system needs to provide that functionality back to SQL Server because it's a pretty high-end product. It does some pretty sophisticated things. And so my guess is, this is just my total conjecture, is that they tested on, they used RHEL, and the ones that they tested on, because those things meet those requirements, right? And I think that's probably the best answer for that. Certainly you could get it to work somewhere else, but the product team has to support certain things and also know that those features that they need are provided for the product that they're trying to deploy.
Okay. And one last question. What are your thoughts on the direction for SQL Server on Nano Server versus SQL Server on Linux?
Do they have Nano?
Because it seems is more committed to Linux. I'm not sure whether they're meaning Docker.
Or are they talking about server core, maybe?
So we'll get more information and we'll come back to that one.
Okay. So we just finished the install. Remember, the last thing we did was this, right? It's like coming back from commercial. We're going back into the demo. So the last thing we did was that. And now SQL Server needs me to run a setup utility to get SQL Server to a state where it's up and running. Now, like I said, we're not focusing on SQL Server today from a demonstration plan standpoint, but I'm using this to show you how packages work and Yum work. And we're going to go and we're going to look at how systemd works. And so I'm going to install Developer Edition because it's free, but this is certainly not a production system. And I am going to give it an administrator password. I have only 125 days left for my demo. So there we go. So we can see right here, we get this great line that says SQL Server is now up and running. We can use PS to figure out if our process is up and running. So PS minus AUX, grep SQL. What that's going to do is, we know the first part, right? Big giant process listing. We know what the pipe does, right? It's going to take that information. It's going to pass it into the command on the right. And this command grep, what that does is it searches for text patterns and strings. And the pattern that I'm looking for is SQL. I hit enter and I get, instead of the huge process listing, I just get the lines that meet that SQL search parameter. So we can see I have 2 SQL Server processes. And of course I have my grep command because grep was looking for the string SQL. But this isn't the best way to get a good feel for what's going on our system. We're going to leverage something called systemctl to interact with our SQL Server as a process or a service running on a computer. That's just the process data that we looked at with PS. And so with this, it's how do we know what the name of the service is that we want to interact with, right? So we use systemctl, and we can ask systemctl. We can say list unit files. And I told you earlier that all of our systemd units are implemented as files. And what this is going to do is it's going to go and it's going to read all of those. And I get this big giant listing of all the different units that are on my system. So here we can see the service name, excuse me, the unit name says get rescue, and its type is service. So let's go find something that's not a service. We can see if we have sockets and targets. So I talked about targets being different states of the initialization of the system. We have an SSH socket, right? For listening on SSH, we have a syslog socket, which are different types of units that perform different functions. But we want to know where SQL Server is, right? And so let's use that grep command again, grep SQL, to figure out where our SQL Server unit is. We could see mssql-server.service. So the service name is going to be this part, and the unit type, or excuse me, the unit name. And the unit type is service, and it's enabled by default. And so what that means is if I rebooted the system right now, SQL Server will start up automatically with the system boot. And so now let's look a little bit closer at SQL Server's systemd status and say systemctl status mssql-server. And now we get a lot of output this time describing the current state of our SQL Server service. So we get the unit, again, the unit name, mssql.server, and the type, and a text representation of what it actually is. And here you can see it's a SQL Server database engine. The unit is loaded which means systemd knows about and is in charge of this unit. It doesn't mean necessarily it started or stopped, but it's just controlling this individual unit. The unit file itself is implemented in this particular location right here. And we're going to look at that closely in a second. And it's enabled, right? That's the current status of the unit. So if this system reboots, and that's where we're going to get where it comes back up automatically. We can see here that the unit is now actually active and running. It tells us how long it's been up and running for, about 2 minutes and 35 seconds, right? Since that service was started when we completed the mssql-conf space setup process to set up our SQL server, and it initialized the service for us. Got a link to some documentation, and the main process ID for the binary SQL server, right? So it's the binary that's executing right now. In systemd, we have a concept of a C group or a control group. This is kind of an advanced topic, but using control groups, we can assert policy controls on the resource consumption of a service. So we can control things like CPU scheduling, memory allocation, IOPS or disk IO, dedicated to individual processes. So if you do have, a system that's multi-tenant, or you need to massage your performance attributes for particular service units, you can leverage C groups to do that. And these are the two processes that are controlled, that are part of this systemd unit. We're in a control group by default, but there's no policies being applied to this particular system or to this particular unit. So the next thing I want to do is look at, actually we're going to look at this. So this is the unit file in usrlib systemd system mssql-server.service. This is the unit file itself. That is the implementation of the unit that is SQL Server. And so inside of here, it's kind of, you're going to see a lot of information that we saw when we checked the status, right? So now you can see where the description comes from right there. We have an after dependency, right? SQL Server has to start after the network target starts. So that means our system has to be booted up. The network target is processed, which means my system basically has networking now. And we also have to have the audit.d service started as well. So those two things need to be started before SQL Server does. So the unit type is a service, right? And it's going to start this binary that lives in opt.mssql bin SQL Server. So this was the binary that starts up that represents the SQL Server process. The actual user, so all processes of Linux systems execute as users, and so user equals mssql means that this process that is underlying the systemd unit for SQL Server will execute as mssql-server or a named user, right? Not going to run as root or any other privileged account, mssql. Our working directory, so all of our data is going to live in var opt mssql, right? The variable directory is where our databases will live. The kill mode means it's going to kill the processes off when I shut down the daemon or I tell it to stop, and it's going to have a timeout of 30 seconds. I'm going to scroll down a little bit further and show you, that we also have some interesting capabilities enabled by default. We have restart equals on failure. So if this systemd unit fails and does not, the process doesn't stop in a normal state or a regular process exit, systemd will restart it, which is cool functionality, right? So if the thing totally goes kaput and not on a graceful shutdown, it'll just restart SQL Server. Good and bad depending on your perspective. I generally opt towards leaving things off, go figure out what happened, and then go fix them. So let's go ahead and get back into using systemctl again. We're going to stop mssql-server. Throw a sudo in the front of that because we need privileged access to bring the daemon down. Go ahead and give it our password. And for once, no output. It's a good thing. And now let's go ahead and check our status. Now inside of here, we have a little bit different output than we had a second ago because we did something, right? We stopped SQL Server. So the unit is still loaded, even though it's stopped, right? So systemd is still in charge of this thing, and it's loaded in part of our systemd configuration. But now it's inactive and dead. And how long it's been dead for? It's been dead for about 5 seconds. And we can see that the last process ID was 2667, and it exited with a status of 0. It exited gracefully, so it didn't have to restart the daemon as defined inside of the systemd unit file for SQL Server. Now, this output should start to look dramatically familiar to you in a second. We're going to read it from left to right. We have a date. We have a host name. Then we have a process name and a process ID, but this stuff over here should start looking very familiar to you when I do this. This is the SQL Server error log written into journal D, right? And by default, when I check the status of a systemd unit by typing systemctl status MSSQL server, this bottom line here below the output that we looked at previously, this output here is the last 10 lines of log in the journal for this particular unit, right? And SQL Server writes its actual SQL Server error log not only to the file that it wants to write its data to, but it also puts that data into journal D for us to look at later. Since it does kind of run off the screen there, and you get these ellipses on the end here, if we throw the -L option on here, we'll get the full output. I'm kind of have a big font going on, so I have a little bit of wrapping, but this is all output that you guys should be used to seeing. So servers broker start it, stopping SQL Server database engine, always on availability groups are going offline. These are the things that we would see in our regular old error log. So now that we have that stopped, if we wanted to disable the unit, we simply type disable MSSQL-server, and that's going to unlink, or that's going to disable the unit. And what it does is under the hood is it removes a special file type or a symbolic link to the service unit out of the multi-user target. So that is removed. It's no longer part of the bootable system. And if we restart it right now, when we transitioned into the multi-user target or the state that the system boots into by default, it won't load the service unit. We can simply put that back by typing enable. And so that's how you disable something from starting up on boot or enable something to start up on boot. So now that it's enabled, I want to go ahead and type start. And it's going to start that thing back up again, and we'll check the status to make sure everything is good to go. I'll remove that -L. And now we can see we're up and running again. One of the last things I want to show you while we're still talking about things like SQL Server and packages is I want to look at one thing to show you guys how to look at all the things that are installed in our system. We can type RPM query -all, and we'll get a list, a huge vomitorium of all the things installed in our system. Of course, we need to be able to sift through that giant list, and so we know how to do this now with grep and building pipelines. We can filter that list very quickly. We can see I have MSSQL-tools installed and MSSQL-server, and that's a good way for me to go and see what I have going on inside of my system. We can also use RPM to do something like this. So we have the package right there, MSSQL server. So I'm going to grab the package name. I don't necessarily need all the version information or architecture information. I'm going to type RPM query -QL and then the package name. What that's going to do, and I'll pipe that in more so it doesn't shoot off the screen real fast, is that's going to tell me everything that came with the package. And so I can go and I can look very quickly to see the contents of an RPM and where a file came from if I needed to know that information. So let's go ahead and hop back over to here and talk about system resource management. Okay, so system resource management. When we're talking about that, I really want to introduce you guys into a couple concepts to kind of connect the dots between what you're used to in the Windows world and what we have in the Linux world. And when we're talking about resource management in a system or a computer system, we really only care about a couple of things, right? The physical resources that are in our system, things like CPU, disk, memory, and networking, right? And when we're talking about CPU, especially in Linux systems, I'm going to focus on something called load average more so than I'm going to focus on percent CPU utilization. What load average is the length of the run queue for processes that need to get access back to the processor. And so very similar to how processes or threads are scheduled inside a SQL server, right? Things go into a run queue, then they get picked up to be processed by the processor itself. And what we don't want to have is a very long run queue, because if anyone's in the queue to get access to a CPU, well, then that means that they're waiting, right? They're in a runnable state trying to get onto the processor to do work. And if something's waiting, then it's actually not doing the job that I needed to do. So I focus on very high performance systems. I focus on load average to make sure that that's as low as possible and that we don't have any queuing in our processor's run queues. We look at things like on the disk side of the house, of course, we're super concerned about how much space we have, right? We need to be able to store the information that we want. But of course, in database systems, we care about latency. we also have a concept of I/O weights inside of SQL Server, right? You guys, or excuse me, inside of Linux. Inside of SQL Server, right, when something goes into a waiting state, right, it's going to be waiting for a particular resource or physical resource that it has to have access to. Same exact thing inside of Linux, right? Processes can go into a waiting state for I/O, whether it's network or disk or whatever it's trying to reach out to, and then it gets back into the runnable queue, and then it gets back access back into the CPU. Memory, of course, we care about memory pressure and swapping. We want to make sure that we're not exceeding the physical capacity of our system and causing excessive swapping of disk. You hit that point where you start demand paging because you need access to more memory, bad things can happen and your performance will fall off a cliff. Networking, of course, we care about throughput, latency, and reliability. Throughput is how much stuff I'm moving in a time interval. Latency is how fast I'm moving it. And reliability, I need to get it where it needs to go. And that's all going to impact my performance and capacity there. In SQL Server, SQL on Linux implements SQL OS, so we get all the things inside of SQL OS to provide that lovely functionality, things like extended events and DMVs. And so we get all those tools and tricks that we've built up over the years perfectly apply inside of SQL Server on Linux, and we can leverage those things to sift out the performance data that we need from SQL Server. So how do we get this information, right? So I'm going to show you some of the commands that are included with your operating systems and its base repository. So if you install CentOS or RHEL, these things are available for you either right out of the box or with a quick yum install. So top is going to show you a refreshing screen every 2 seconds of what your processes, usernames, things that you saw kind of in PS, but in a refreshing automatic view. Basically think of Task Manager, but in the command line. VM stat is going to show us our virtual memory statistics. Are there processes that are paging in and out due to demand paging, or actually any kind of paging, not necessarily just demand paging. We also have free -m, which is going to show us in megabytes the amount of available system memory, total system memory, cache memory, and things like that available in our systems. That's a good way to get an understanding of who's consuming what from a memory standpoint. From a space standpoint, we have DU, which is you can ask for the size of a particular directory. So DU -chs, and here I have ./dir. That'll give me the absolute size of the stuff that's in the directory dir. df-h is going to give me the output of file system utilization for all the mounts on my system. And I want to introduce you guys to a tool called dstat. It's my monitoring Swiss Army knife. If I'm triaging a performance issue, that's my go-to tool to help me figure out which resource I need to go chase down for my performance anomaly. So dstat will give you a 1-second refresh output of things like kernel time, user time, context switches, memory utilization, page in, page out, IOs, IOPS in a nice structured format. You can also use dstat to output to CSV. So you can build nice charts to figure out what your performance anomalies are, but you're triaging that right now performance issue. If you need to answer the question of what happened when, like when Bob from accounting ran that report yesterday at 3 o'clock and it was slow, and you need to know what happened when, SAR, the System Activity Reporter. What that does is it records information over time and stores it for you and allows you to go back and sift through that data to figure out and query what you want to have access to when. I'm not going to cover these in a demo today, but I do have those available in my Pluralsight course for you guys for at least like an hour and a half of sifting through these utilities to go through some resource management. So I'm going to connect some dots for you guys right now. And we're going to look at the subsystem type. We're going to look at the Windows performance counter. We're going to look at the Linux tool that you get that same data from, and the Linux concept, the performance concept that we're trying to connect here. So if we're looking at CPU utilization on the system, right? If you want the perfmon, you would go look at percent processor time. On Linux, you would use top. I actually like to use a tool called htop, which is available in EPEL. So you add the EPEL repository, you install htop, and that's a fantastic utility for that. You're going to focus on CPU utilization or CPU usage and load average. I said I don't like utilization earlier. That's still true. Memory. So you guys looked at percent committed bytes in use on Windows. Free -m is going to be on the Linux side of the house. One of the things about Linux is I can get this information from a lot of places. I can actually get it from top, and I can get it from htop, and several places I can get it from IOStat, but free is kind of the core utility that one would use. And the questions that you want to answer are: what is my total memory? What's the current used memory? How much do I have free? And how much is being dedicated to the file system cache? Disk space, so percent free space, we do the perfmon counter that you would use. df minus h answers that same question, so we get total used and available from a space standpoint for all the mounts on our system. IOs, disk transfers per second. That's what we looked at in Windows. IOstat minus DX, right? What IOstat minus DX is going to give you transactions per second, or TPS, reads per second, and writes per second. So you can go and you can figure out which disk subsystem is churning through a bunch of data. Disk latency, where SQL Server Pros, we care a lot about disk latency. Average disk seconds per transfer, right? IOstat minus DX. Service time is the column that you want to look at in the output there. I have a bunch of asterisks on that because service time, I don't want to say is becoming an unreliable counter, but service time doesn't account for NVMe parallel queues very well. It's used to the kind of the older style SATA serial dispatching of IOs. So the counters right now for NVMe aren't accurate, but if you're on SATA style disks, you're still good to go. IO size, again, SQL Server Pros, we care about IO size, and it also correlates back to latency, right? Bigger IOs will take longer time. So we need to look at both of these values. Again, you can get that from average disk bytes per transfer. IOstat minus DX will answer that same question. Average request size is the attribute that you want to look for there. Interface, this is my favorite perfmon counter ever, because if we're going to go look at the perfmon counter bytes per second for our interface throughput for our network interface, I don't know a network engineer on the planet that measures network throughput in bytes per second. Here we have it in bytes per second. Generally, they use bits. If you go Google, Linux network monitoring utilities, you're going to see like the first couple blog posts, or first couple lists in Google are going to be the top 20 network monitoring tools for Linux, because there's so many available. The ones that I like to use are IFSTAT, BWMNG, or Bandwidth Monitor Next Generation, or nLoad. BWMNG has been the one I've been using forever. And we look at things like packets per second, and we obviously want to measure it in bits per second. But do check out DStat, right? I said it's a Swiss Army knife for a reason, because it can do almost all of these. And not only that, DStat's extensible, so you can write your own plugins to answer questions that you might need to answer. And so one of the things that I've been thinking about is leveraging DStat to connect that up into SQL Server, maybe execute some DMVs or get some other performance data so we can correlate back to our physical resource utilization from our operating system. Be pretty fun stuff to do that there. So I promised you at the beginning of the course, I was going to tell you where to get some help, right? So the man pages are the primary way that I get help on my Linux systems. And all of that stuff is available at your fingertips right now. Anything that you install will have a man page that goes along with it, and will be a fantastic way to explain to you whatever you're looking for and how it works. You type man and then the command that you're looking for. So let's say I was using man SQL Server, I type man SQL Server, and it would give me the help file for that particular program that I want to execute. PS, same thing, man PS, and I get the output for that. I get the man page output for the thing that I'm looking at. If we're in PowerShell, we have get help, and I want to let you in on a little secret, not necessarily a secret, but the thing that's often forgotten about is local documentation. Anytime you install a software package, what it's going to do, it's going to take its documentation, it's going to park it in USR shared doc in that directory. And inside there, you'll find things like help files, README files, you'll find example configurations and default configuration files. And so, if you install Apache and you go and you look in that directory, it's going to be USR share doc HTTPD-2.4.6, which is the current version. You go in there, you're going to find a default Apache configuration file. You're going to find virtual host, SSL configs. And the point is, those are great resources if you need to go look at how to configure certain things on your Linux system, not just Apache, anything that's installed on your platform. So the key takeaways from today are, it's just an operating system, right? Once you get over to the syntax and the environmental changes that exist inside the system, a lot of these concepts are the same, right? We're looking at an architecture where we're executing commands, we're looking at how it manages its physical resources. They do the same things, right? We looked at the Linux architecture, we looked at IO redirection and text-based pipelines, or byte stream-based pipelines, core concept of how Linux works. File system basics, kind of pointing you in the right direction on what to go read tonight when you want to go to sleep, about the file system hierarchy standard, but really where Linux stores stuff. PowerShell and Linux, again, a good way to bridge the gap for you guys. We talked about installing packages and where to get that stuff from, and systemd, how to start and stop or enable and disable services. and some of the core utilities that you can use to poke and prod your Linux system to find that perf data that you need to solve that performance issue that you might have or benchmarking that you're working on. So here's some of those courses that I was telling you about that's kind of the core of today's talk. The first course, Understanding and Using the Essential Tools for Enterprise Linux 7. Basically, I take you from sticking the DVD in up to running advanced pipelines and shell topics. Fun stuff there for you guys. Cover file permissions and managing files and directories in there. Deep dive on file permissions, actually. Advanced Network and System Administration. This course is about 6 hours long with deep dive on service monitoring, performance monitoring, package management, making your own packages, configuring in repositories, installing and configuring NFS and Samba and Kerberos are all covered in that course as well. So if you need some more information, there's my contact info again. Does anybody have any questions?
Okay, so Anthony, we've got one question around, is there any implementation of SQL Server in Linux distribution?
I don't quite understand the question, sir.
If the person is still online, if you can add some more details, we can come back to that question. Are we able to get a copy of your demo? Will you be able to send that through to me and put it up with this recording?
Yes, I sent it in this morning, so that should be linked, but I also put all of my stuff on this URL here, so syncinosystems.com/blog/talks. And so all of this will be available. I'll put it there tonight, if not first thing tomorrow morning, or the exact opposite for you. But I did give it to the group, and that probably be distributed via the normal distribution mechanisms.
Okay. Okay, so I think so the person's come back around in a production system. I would probably say no, given that this is only a support in 2017, and 2017 is not out yet.
Right.
So everything, just so everybody's aware, everything that Anthony was talking about today is supported in SQL Server 2017, not prior.
Right. Yeah, I think the core of this, though, I don't want to be laser focused on SQL Server, but I wanted to kind of show you the universe around SQL Server that's going to be available when the product is released.
Okay. Is there a way to perform a restore of a SQL Server backup taken on a Windows environment and restore it on a Linux environment?
Absolutely, 100% yes. So remember when we looked at that process diagram, it is Windows SQL Server running inside of that Linux process. So it's going to process that data just like SQL Server would. So you can restore that data. Obviously, the constraints of going up and down are going to be an issue. So you always have to be going to a newer version. In this case, you would for 2017. But yes.
Okay. So with that, I'd like to thank Anthony for coming along and presenting to us today. I'd like to thank everybody for coming along and putting in your questions. This, as we've said previously, this session has been recorded. It will be up and available on the DBA Virtual Chapter archive site probably later this week. So feel free to come back and rewatch this fantastic session from Anthony. With that, we look forward to hosting you all and seeing you all online in another session shortly. Thank you. Bye-bye.
Thank you, sir. Appreciate it.